This is the design concept initial page, and then you're going to open the further pages from here. He is creating the borderline, and it's quite easy process. Borderline creation is quite easy, as you can see, and it can be amended, revised, changed. It's also easy. What Izuka-san is emphasizing here is that the borderline on the surface is quite easily drawn, right? And other software cannot be done. But design concept, you can see that the borderline on the surface, and it can be drawn as whatever you want. So this is quite different point. I mean the strong point of the design concept software. That's what the Izuka-san is emphasizing. Yes, it can be moved. Yeah, right. The borderline can be moved on the surface. Yes. basically, this cushion is symmetric, and symmetric design that you are going to design half, and then after mirroring, it's going to be duplicated on the other side. So Izuka-san is going to work on half side of the cushion, and it's going to be duplicated or either folded to the other side of the direction. So that's what the Izuka-san is going to work on. He is going to make a part definition, identify the parts definition. Now he created the one part. Then creating the second parts and the third parts. And next. All right. Now he created the four parts, and then he's going to do. He's going to use the mirror function. To identify each parts, that the design concept is using the triangle mesh. After this, the design process in 3D, it's going to be flattened to the 2D, and this triangle mesh is going to be used for the a proper calculation to flatten the each parts. And this triangle mesh size dimension can be changed upon your request. Talking about the size of the triangle mesh, it can be smaller, it can be bigger, but depending on the size, the data, if you're going to use the small triangle mesh, you're going to use more data amount. So that's why that the PC is going to be slowing down, so that the you will have to identify the best size of the triangle, depending on the design. If you're going to design the complex parts, small parts, if that would be the case, that you better use the small size of the triangle mesh. But if you're going to design that the kind of bigger parts and simple parts, then triangle mesh can be bigger, not to use too much of the data.1 millimeter. これミリメートルですよね。
そうです。
0.1 millimeter, but now the PC is freeze, right? So it's too small. So I don't think it's a proper length of the triangle. It should be 1 millimeter. If you enter that the 0.1 millimeter, it did not work.
Yeah.
So that it could probably be that the 1 millimeter as a minimum, maybe. But yeah. In fact, that Izuka-san never tried at the 0.1 millimeter. But yeah, you can enter. Yeah, three minimum 3 millimeter up to the 10-15 millimeter. That's what the Izuka-san, Mr. Izuka, have seen in the Japanese automotive suppliers. In fact, that the triangle length 0.1 millimeter was entered into the software. That's why that the his computer is still thinking. So just a moment, he's going to help us out. I mean, the Izuka-san is going to help us out. To make the flattening, you will need the borderline and triangle mesh and notches, right? Then you can have all the 3 items to identify the parts, and then you can go for the flattening process. And then flattening process is in place, and Izuka-san is working on it. And flattening process done. If the triangle size is small, you can take more time. You take more time to complete the flattening process. The fast modes prioritize the lengths. Prioritize the lengths of the parts. Okay. But standard mode prioritize the area. I mean the space. You know what I mean? So standard mode prioritize how the parts size is. I mean the space. I mean area. Okay. So area of parts is prioritized by standard mode. That's why the flattening calculation is basically from center point to the outside. I mean the side. This is a standard from center to outside. See? Sashison-san, I hope I can explain and reply to your question as much as possible. But the standard mode priority the area size of each part. Okay.
Okay.
Okay. That's why area size is going to be highly likely the same as the one of the 3D and after the flattened. But
Okay.
you know, parts lengths outside
Yeah.
may be different, right? Because the priority is different.
Okay.
Priority is on area size.
Okay. Okay. Understand. So
Understand?
yeah, understand.
Okay.
This one, you can go to next step.
Okay. Maximum, you know, differences in 3D and 2D. So it's depending, answering to your question, it's depending on the, you know, piece shape, either the, you know, the design itself. And according to Izuka-san, it can be, you know, a few millimeters up to the over 10 millimeter. It's depending on the, you know, design shape. But yeah, but you know, the most important thing we need to emphasize here is that the, you know, real mock-up, you know, the number of doing the, you know, real mock-up is going to be decreased by the you know, digital designing. You know, of course, that you try that you may have to go through the trial and error because 3D to 2D, and then okay, you're going to paste it into the 3D mock-up, and then that correctly it's not pasted onto the 3D mock-up. It can happen, of course, but the number of those that the real checking is going to be decreased, and then it can be saved in the data, and then you can check that data after, right? That's the most important things of this, that the software usage. I hope you understand, but I know yes, it can be changed depending on the size, the design of the shape, and yeah, it can be fine-tuned, of course. It will have to be fine-tuned, of course. Previous data was pretty much simple, so that he's going to change the another data. You see, this is the very preliminary tension analysis. But this tension analysis is not the considering the cushion characteristics, either fabric characteristics, how it can be stretched, how it can be at the shrink. Those type of things are not considered in the analysis you see. But the tendency of the design should be the same, should be very similar. So this can be used as a preliminary level of the consideration for your designing. Then yeah, you can identify that each part's shape onwards. Okay, and then you see that the yeah, now Izuka-san is adding the 3% maximum, and bottom is -3%. Then how that the this C design is at the having the tension on each area, right? And the red means more tension, high tension. Blue means that it's less tension. And fortunately, this design is having that the most likely that the 0% tension on each areas. Little tension on that the front sides on the left and right. But yeah, this is how you see, and you can identify how the design is having the tension in each area. Now going into the fixation, design fixation processes, as Izuka-san showed, the right side data, area to area, you see some that the length difference for the sewing. Okay. For example, he's showing on the here, right? And then you see that the red color and black color. That's a sewing counterpart. And on top of that, the parts that the you see yeah, red color, and the bottom is showing that black color. Yeah, or now the opposite, right? And this is the sewing area. Each other. So if you have the variance, I mean differences in the lengths each other, sewing operators will be in trouble. So that's going to be adjusted in the design, in the design activity. And now Izuka-san is working on that the adjustment. And now the you see 1.124 millimeter differences. I mean length differences in respective parts for the sewing counterpart, and this will have to be adjusted, right? Now you have 1.124 millimeter differences. Red length
Mhm.
is 62 point
Yeah.
something, right?
That-
Length is not the same. It should be adjusted. Should be fine tuned, right? And that now after flattening, those type of processes coming in. That's what the Izuka-san is saying.
uh-huh.
After that, the fine tuning of the each length, he is going to create each cutting data. So you see the scissors mark, and then these are the 2D design that can be cut by the cutter. He's going to add the seam at the very quickly. It can be, upon your request. It can be at the 10 millimeter, 8 millimeter, or 7 millimeter. It's up to you. piece shape can be imported into the design concept from GABA to the Lectra. I mean, design concept. But definition of the length. I mean, the dimension information may be different in between GABA and Lectra. I mean, it cannot be imported into the Lectra. That's why that it should be after importing that the shape itself. You are going to identify the dimension or the length in the Lectra software. That's what. This is the initial page of the DC design concept, and then design concept 3D is having the 4 pillars. Okay, and the 2D is having the bottom 2 pillars only. You see that the 2D working already in the Izuka-san's screen, right?
Yeah.
And this is part of the 2D DC design concept 2D area, but DC 3D is including those, right? Let me rephrase, okay? If customer buy the DC3D and DC2D, you could see that the 4 pillars.